Hey everyone. I've been working with a number of Mantel's clients implementing Databricks, both on AWS and also on Azure. Back at home, I've been watching a lot of dad TV. I don't know, are there any dads here today? Okay, one, two, three. Excellent, thank you. There's a show on there called Building the Ultimate, and maybe inspired a bit by that, and a lot by my experience working with Databricks customers. I wanted to show you today how to build the ultimate Databricks environment. Now, I'm not suggesting that this is going to be the perfect Databricks environment, but if you're using Databricks at the moment, or you plan to in the future, hopefully you'll learn something along the way. If I can get the clicker to work. Thank you. So I'm going to cover the main pain points as I see them. So planning, networking, some CI/CD, disaster recovery, and some tooling. At the end of this presentation, I'm going to share a link to a repo where I've set up all of this inside of Terraform. If I've timed it right, there probably isn't time for questions, but I've left my details at the bottom of this slide, and I'll also be at the Mantel booth later if you've got any questions. So my name is Stu. I'm a lead engineer for Mantel Group. Mantel Group is one of Australia and New Zealand's leading consultancies with specialists in data, digital, cloud, and security. We are an elite Databricks partner, a Microsoft partner, an AWS Premier partner, a GCP Premier partner, a Snowflake partner, and probably many other besides. We've got hundreds of certified professionals working across various domains, so if you've got a project and you think we can help, please do reach out. Okay. So for anyone who's just starting out with Databricks, here's a very quick recap. So Databricks is an integrated cloud platform for data engineering, data science, and machine learning. It's built upon Apache Spark, which is an open source engine for large-scale data processing. Databricks was started in 2013 when the creators of Apache Spark wanted to create a managed Spark platform. And unlike a traditional data warehouse, Databricks separates the compute from the storage. Data and storage is in the form of Azure storage accounts or S3 buckets, with compute being in the form of on-demand Spark clusters. Generally, this makes it significantly cheaper and more scalable than your traditional data warehouse. So Databricks splits itself into three sections or planes, and we're going to talk about these a little bit later. So the control plane, this is a Databricks managed AWS or Azure account, and this is typically what you interact with when you're using the UI or API. Then we have the classic compute plane. So this is your cloud account, and you grant access from the control plane, and this is then used to create either EC2 or VM resources. It's also the place where all of the data is stored. In 2021, Databricks created the serverless plane, and this is another Databricks managed account, and that's where all of the serverless jobs and clusters reside. If you're looking at really old documents, you might see the compute or data plane, but this is just the same as a classic compute plane. They've just renamed it over time. For the most part, this talk will be platform agnostic. The principles should be the same regardless of whether you're using AWS, Azure, or GCP. But I'm going to specifically focus on AWS and Azure. But if you're using GCP, the concepts should be broadly the same. It'll probably be useful if you've got a basic understanding of how compute, storage, and encryption work in those platforms. But if you haven't, hopefully you'll still learn something. Okay, now we've covered the basics, I'm going to look at some of the things you need to consider before deploying Databricks. So I recently did some work with a client, and they wanted to migrate from Databricks on Azure to Databricks in AWS. And you might well be wondering why, like Databricks hasn't been around for that long. Well, the reason that they wanted to migrate was because they had deployed to an AWS region that didn't support serverless, and they wanted to use serverless. They also wanted to utilize some of the high-powered GPU-enabled clusters on AWS for some ML workloads that they'd developed. Why am I telling you this? Well, I want to explain the importance of proper planning. We've seen quite a few similar stories, and hopefully this presentation will help you avoid some of those common pitfalls. So although the core of the Databricks is the same across all of the hyperscalers, it's important to understand there are some differences. So on cost, initially, Azure might seem more expensive, but it's important to understand that this includes support and typically also the VM cost as well. Whereas in contrast, on AWS and GCP, you're going to pay for the underlying compute, plus typically between 8 and 15% extra for support. Features-wise, it's broadly the same across all of the platforms, but we have noticed that on AWS typically gets features slightly ahead of Azure, with GCP normally following a few months behind. Integrations-wise is probably where there's the biggest difference. So Databricks on Azure has out-of-the-box integration with things like logging and budgeting, and this can make it significantly quicker and easier to deploy on Azure. AWS does have a budgets feature coming as a preview on Databricks. Billings-wise, Azure also provides consolidated billing. AWS does this as well, but only if you purchase Databricks through the marketplace, which probably isn't the route that most enterprise customers are going to go down. Regions is another significant difference. So it's worth noting that on AWS, there is currently only one region in Australia that supports Databricks. On Azure, there are more regions, but as previously mentioned, just make sure you check the features because they're not the same across all of the regions in Australia. We did have another client who deployed Databricks to the Sydney region. They had a Power BI capacity in Singapore, and as a result, they saw some fairly significant latency and cost. So it's not just considering where you're going to deploy Databricks, but also kind of think about all of those services that are using and consuming Databricks. Okay, next we're going to have a look at setting up workspaces. So one of the challenges we've seen across all clients is setting up the right workspaces. And there's no universal plan for this, but this is a model that we've used a number of times, and we've had some success with this model. So firstly, we split between two distinct infrastructure environments, so a prod and a non-prod, and these could be accounts in AWS or subscriptions in Azure. This enables you to lock down production so that it's break glass, limited access only, while still giving fairly liberal access to non-prod for developers and engineers to try things out. There's an optional sandbox environment for testing out infrastructure changes, and this is particularly useful for testing things like bucket policies on AWS or private link, and these are best tested in isolation. If you want, you could destroy this once it's been used to save on cost, but that's up to you. Dev, test, and prod should be fairly self-explanatory, but you'll see from the diagram we've also added an ML analytics environment. We've found this is particularly useful where people are looking to develop things where they need production data, but want to avoid developing things in prod, obviously. To do this, we have shared the prod catalog with the ML analytics environment as a read-only catalog. There's also a DI environment shown on here, and I will cover that at the very end. It's fair to assume that we should have CI/CD pipelines that are promoting everything through these various environments. And finally, the accounts in this diagram is an assumption that they are set up in a hub and spoke type model with on-prem connectivity, firewalls, and etc., all kind of routed via a central hub. Whatever you do, you should plan whatever works best for your organization, but hopefully there are at least some things you can take from this design. Before I move on, just a quick note about subnets. So an essential part of setting up the right environment is having the right network to support this. Databricks clusters use two IPs, so one for the host and one for the container. And AWS, we obviously need to distribute these amongst multiple availability zones for high availability. You probably also want to factor in things like private link, which we're going to talk about later, CI runners, bastions, and any other kind of parts of your network. Okay, one of the most challenging bits we've seen with any Databricks deployment is private link. This subject comes up again and again when we talk to customers. If you haven't already implemented private link, this is absolutely something you should consider. And in order to use private link, you must be using the premium tier and have deployed your own VPC, so not using VNet injection, or sorry, using VNet injection. It can go wrong. When it does go wrong, it can leave you unable to access your workspace, which obviously isn't good. So it's probably something that's best tested out inside the sandbox environment. So before we go too much further, let's just take a quick look at what private link is. So private link is a shared term between Azure and AWS. There are subtle differences, but for what we need to know for Databricks, the process is pretty similar. So why do we need private link? Well, as most people probably know, when we deploy a service like a VM or an EC2, it gets deployed inside a VNet or a VPC. In most cases, if I send traffic between two VMs in the same VNet using the private IP, that traffic isn't going to get routed via the public internet. It will go across the VNet. And that same logic applies if there are VMs in different VNets. But how does this work for other services? Well, for many other services like S3, storage accounts, KMS, etc., these obviously aren't hosted in your VPC. By default, to get to these services, traffic will get routed across the internet and use the public IPs that are associated with these services. Traffic going over the public internet can cause a number of problems, including data security, data regress costs, network latency, and in some cases, even data sovereignty issues. Well, in 2015, AWS released what would later become Private Link, with Azure following a few years later. Private Link works by providing a private IP inside your VPC or VNet, so that you can use services like S3 and storage accounts without the traffic going over the public internet. So there are a number of ways that we can use Private Link. Perhaps the most simple is from classic compute to KMS or Key Vault or some other kind of cloud-based storage service. In many cases, this is probably something you've already set up. It's certainly best practice on all of the cloud platforms, and it's not necessarily specific to Databricks. To enable this, we just need to create a private endpoint to the required service from inside your VPC or VNet. In the case of Databricks, the cluster will then use the DNS to resolve to the private IP, the private endpoint, with the private endpoint, and then any traffic using the private IP will get routed through the AWS or Azure backbone rather than going over the public internet. It's just the same as if it was communicating between two VMs over the same VNet or VPC. So you might have been wondering, well, if that's how, if I can set up private endpoints to access cloud resources from classic compute, well, what do we do with serverless? Well, the model for serverless is broadly the same. The key difference here is it runs inside the serverless control plane, and obviously you don't have access to set up VPC endpoints inside that because it's owned by Databricks. What you can do, though, is set up a network connectivity configuration. Behind the scenes, this does the same thing, so it just sets up a private endpoint inside the Databricks serverless plane, which is linked to a specific resource inside your account, so for example, an S3 bucket. With this in place, traffic from serverless compute behaves exactly the same way as it did in the previous slide, with using the private IP and the traffic getting routed over the backbone. Conceptually, this is also how it works on AWS for S3 and DynamoDB. But for other services, and I won't go into why, but for other services like KMS, you actually have to whitelist from the stable IP that's provided by the NCC. So it's a little bit more complicated to set up. Currently, serverless is obviously only available for SQL warehouses, but it's in private preview for everything else. Okay, next we're going to have a look at how we secure traffic between the control plane and your clusters. So to do this, we need to implement backend private link. Here, rather than directing traffic out to an Azure or AWS service, we're directing the traffic to the Databricks control plane. Now, the process is a little bit opaque, but this is how it works without private link. So the control plane uses the AWS or Azure API to create a cluster inside your VNet or VPC. For AWS, it uses the cross-account role. For Azure, it uses a service principal. The provision cluster is assigned with a public IP so that the Databricks control plane can control that instance, so it can shut it down, it can run jobs, etc. All of the traffic still stays in the backbone, but it's still using a public IP to access your cluster. If Databricks needs access to a resource, so it needs data from a storage container, for example, as the cluster is running inside your VPC, it will use the private link for platform services we saw on the previous couple of slides to get that data. So again, using a private IP. With backend private link enabled, it still uses the same API to create those resources, but this time, when it creates the cluster with a private IP. And then uses this to control the instance, to run jobs, shut it down, etc. So in this example, there are no public IPs used to communicate between the control plane and your classic complete plane. Next, we're going to have a look at how we secure your workspace. Now, there are a couple of ways of controlling access to Databricks workspaces. The easiest way, by far, is to use access control lists. This just lets you specify a list of IPs that can be used to access your workspace. But obviously, at scale, that becomes difficult to manage. So the other way we can use this, do this is using front-end private link. So with front-end private link, the first thing you need to do is set up a private endpoint that points to the control plane. With this done, we now have a private IP inside our VPC that we can use to access that control plane. We can then configure any DNS records to point to this private IP. And finally, we block public internet access to the workspace. This prevents any public traffic from accessing that workspace. Obviously, with this setup, the only access you're going to get from that workspace is inside that VPC or anything linked to that VPC. So in order to then use your Databricks environment, you either need to be using on-prem connectivity or some kind of bastion. It's worth noting that this also restricts many SaaS services. So things like Power BI will no longer be able to connect to your workspace. There are ways around this by whitelisting IPs, but in the case of something like Power BI, we can use Power BI Gateway for doing this. So with all of these private links set up, everything in your Databricks environment now should be secure and using private IPs where possible. Next, we're going to have a look at how we deploy Databricks. So we've probably all been there. We kind of join a new company or a project, and the first thing you do is you set up your environment. You set up your tooling, you install VS Code or whatever floats your boat. Day two of the project, you do your first code change, and you get an error. And you spend the day going back and forth between Google and the documentation. Hopefully there is some. Eventually you figure out you're using the latest 3.4 and everyone else is using version 3. It's a classic, it works on my computer problem. Hopefully, maybe not hopefully, but it's certainly one that I've encountered on a number of occasions. So the Three Musketeers pattern is a strategy that uses make, Docker, and Docker Compose to minimize the amount of tooling that gets installed on your each engineer's development environment. By installing the tooling inside of Docker and version controlling it, any tools work the same across all of the platforms and environments. Typically, this is probably most useful when deploying infrastructure where you're using a lot of tooling, but there's no reason why this couldn't be part of your engineering pipelines as well. Additionally, we can use the same CI/CD pipelines, same pattern inside your CI/CD pipelines, so you've got the same common tool set working across all environments. Okay, I'm going to have a look in a little bit more detail. So the first thing you need to do is define a Docker file. This contains everything, all of the tooling that you need to run. So in this example, I'm using a Python base image, and I've installed things like Terraform, Databricks CLI, Azure CLI, Terraform docs, etc. But this is just an example, do whatever you want inside Docker, install whatever tooling that you need. We can also push this to a Docker registry if we need to, so that's version controlled. But as you'll see from this next slide, I'm just going to build it each time. So then we need a Docker Compose file. This obviously references the Docker file. And for engineers, laptops, and development environments, I've mounted in the credentials for things like Azure and AWS and a Databricks CLI. Obviously, using this inside a CI/CD pipeline, you probably want to pipe through things like secrets and access tokens using environment variables, but the process is broadly the same. Finally, we need a make file. So the make file brings all of the commands together into a single place. And as you can see, it uses Docker Compose, run, and then whatever command it needs. So in this example, I've got a Terraform plan. So I'd use Docker Compose, run, the name of the image. So in my case, it's just called build. Terraform plan, which is the command I want to run, and then the RM bit at the end just removes the container once it's been run to keep things nice and clean, so we're not kind of spinning up lots of containers. As you can see from this example, I've installed a number of tools inside this. So for static code analysis, I've got things like TFSec, but I could have used like any number of different tools, so Snyk or Chekhov or anything like that, and it just gives me feedback on whether the infrastructure I'm going to deploy is secure. For linting, I've used TF-lint, but again, lots of things available. For costing, I've used InfraCost, and again, this just gives me an estimate of roughly what that infra is going to cost to deploy. And for documentation, I've used Terraform Docs, and this just automates the documentation that, automatically documents the kind of Terraform that's been used. Okay, next I'm going to talk about disaster recovery. So if anyone's read the Databricks documentation, you may notice that it's a little bit light in some areas, particularly on the DR page is how you actually deal with the data. So it goes into great detail about how you deal with notebooks and policies, but skips over the actual data. So before I go into this, it's probably worth mentioning a few points. So first of all, with your catalogs, just make sure you are storing the data for these in specific storage locations rather than inside the actual physical metastore location. This makes it much easier to unpick everything and also allows you to kind of tune those storage locations. Ensure everything's inside infrastructure as code. So all your jobs and notebooks and everything else are stored in repos and are stored in infrastructure as code. Finally, your Databricks deployment, in most cases, should already be AZ resilient out of the box. Just make sure your clusters are set to auto availability zones and your jobs have a retry policy. Databricks recommends about 15 minutes to restore the control plane in the event of an AZ failure, so just kind of factor that into any jobs. So there are a few options when it comes to DR. By far the easiest and potentially slightly controversial one is to just do nothing at all. Regional failure is pretty unlikely. If it does happen, depending on the nature of the failure, you potentially have bigger problems on hand anyway. And in most cases, this is a data platform and probably something that's not necessarily mission critical. The second option is to replay all of your data. So take the data out of your storage location and into a cross-replicated storage location. Obviously, the issue with this is you have to re-import the data if you needed to fail over. And clearly, if you've got a lot of data, that's going to take a long time to do. So the third option is what's on screen now. So this deploys a pilot light or MVP version of Databricks into a DR environment. We then use Delta sharing to share that catalog over to the second region. And then a scheduled job runs that persists that data using a deep clone into the physical storage in that second region. So the final thing I wanted to look at was some tooling. And the first tool I want to mention is the Databricks SAT tool. So this provides a point-in-time snapshot of how secure your Databricks workspace is. I'd suggest that before deploying it, you amend if you're doing it through Terraform, amend the node size, because I think it's like an extra large cluster with 5 nodes to run it, so it's quite expensive. There's basically 2 jobs that you need to run. There's an initializer, you run this once, it deploys all of the resources and a catalog, and there's a CSV file that you can then tune it with. Finally, there's a SAT driver notebook. This just refreshes the data behind that notebook. The second one I want to talk about is system tables. It's, I suppose, not really a tool, but last year, Databricks released system tables. Off the back of this, various people have kindly created kind of various dashboards. I've linked one of them below. But there are a couple of things that are worth mentioning. So costs-wise, it only shows list prices, so it doesn't include any enterprise discount. Obviously on AWS, it's not going to include the underlying cost of that AWS infrastructure. These costs aren't real-time, so they're updated throughout the day. And annoyingly, there's no lookup between the Workspace ID and the Workspace name. So the way I've got around this in the past is to just edit the SQL statements and put a case when around it so you can actually see the Workspace that it deals with. So that brings me to the end of my talk. Hopefully, as you've seen, that building the ultimate Databricks environment isn't about perfection, but it's just about tailoring it to meet your demands and needs. Thanks for your time today. The link to the Terraform repo is on that QR code and written below. I'm always happy to connect, so feel free to reach out on LinkedIn or just come say hi later. Thank you.